Welcome to the first of 3 presentations for Unit 6. In this one, we'll be looking at topics 6.1, 6.2, and 6.4, renewable and non-renewable resources, global energy consumption, and distribution of natural energy resources. When thinking about energy use, images of electric devices like light bulbs, televisions, and cell phones probably come to mind. Additionally, the utilization of fossil fuels for the production of gasoline, diesel, and jet fuel for use in our transportation machines are likely to come up in that brainstorm as well. But energy use actually has a much more diverse and longer history, since it includes how our earliest ancestors would have relied on fuel sources like wood and animal waste for cooking and staying warm. Starting with the Industrial Revolution in the 1800s, energy production use has evolved technologically and expanded exponentially. Our modern society's functioning requires the use of vast quantities of energy, and that presents complex problems with far-reaching consequences on a global scale. Energy is defined scientifically as the ability to do work. Most energy production in developed nations is for the purpose of generating electricity or producing fuel for transportation. We can consider the work being done by the energy we produce in one of 4 generalized categories. Transportation, which largely relies on fuel like gasoline or diesel, but can also include electricity in the case of fully electric vehicles. The second category is electricity production, which is distributed to businesses, schools, and homes, powering our televisions, lights, computers, and of course all of the chargers we need for our cell phones, laptops, tablets, etc. Energy production is also important in heating our businesses, schools, and homes. In some cases, this is accomplished with heating devices that rely on electricity, whereas others may be powered by a fuel like natural gas. The fourth category of energy use is for cooking, which can be powered by electricity or fueled by natural gas. Although there are a number of units of energy which can be converted into each other, the SI unit that is used is the joule, denoted by a capital J. Energy use can be categorized in yet another way into 2 quite broad groups. The first is commercial energy use, and the one you are most likely to be familiar with. Commercial energy is the production of electricity or fuel which is then sold to a consumer. The gasoline that you purchase at a gas station and the electricity that you purchase from a utility company are good examples of commercial energy sources. As you can probably imagine, energy production on a commercial scale is necessary for developed societies like ours to function. Subsistence energy sources, on the other hand, are on a much smaller scale. Subsistence energy sources are those gathered by individuals for their own immediate cooking and heating needs, and include things like wood, charcoal, and even animal waste. There is much greater use of subsistence energy sources in developing societies. Energy resources that cannot be replenished once they are used up are called non-renewable. They are consumed at a greater rate than they are naturally formed. Examples include the fossil fuels coal, natural gas, and oil, as well as nuclear fuels. We will explore these energy resources in a subsequent presentation. Renewable energy resources are those that are replenishable and are non-depletable, like solar, hydroelectric, wind, tidal, and geothermal, or potentially renewable as long as we don't consume them faster than they are replenished, such as biomass. These forms of energy production will also be looked at in much more detail in a later presentation. The resources used for either fuel production or electricity generation are not distributed evenly across the Earth's surface. Where the resources can be found and extracted is entirely dependent upon that area's history. Millions of years ago, the type, distribution, and density of organisms, as well as geologic processes, influence the quantity and quality of energy resources we find today. For example, the existence of coal that is used for about 1/4 of the world's and over 40% of the US's energy production was made possible over 300 million years ago due to large forests comprised of woody plants and the presence of substances within those plants that allowed for them to fossilize. The ever-shifting plates of the Earth's crust transported land masses and the coal fossil fuel within them to their current positions. We will learn much more about coal and its significance in the next presentation. The other two fossil fuels, oil and natural gas, collectively are referred to as petroleum and share similar ancient origins. Most of the formation of these fossil fuels are the result of aquatic organisms that lived 66 to about 250 million years ago. Their presence in shallow waters and specific locations has given rise to petroleum-rich regions like the Middle East and Russia. Just as with coal, we will see oil and natural gas reappear in the next presentation. On a global scale, fossil fuels are by far the most widely used resource for energy production. Coal and natural gas collectively comprise about half of energy consumption and are most important in the generation of electricity. Oil makes up about 1/3 of energy consumption, mostly in the form of fuels like gasoline and diesel. Not only are fossil fuels currently the most consumed energy resource, but they have also experienced the greatest increase in consumption. Our species' addiction to transportation, for example, is largely responsible for driving the increase in oil consumption. In the second half of the 20th century and the first 2 decades of our current century, energy consumption has seen explosive growth. This correlates perfectly to increasing industrialization and development around the world, as well as population growth. From 1950 to 2020, Earth's population grew by over 5.3 billion. Industrial energy accounts for over half of all global consumption. This helps to explain why countries and regions that are becoming increasingly industrialized, such as China and India, have seen the greatest increase in energy demand. Of course, this demand is compounded by population growth and size. On every scale, from local to national and even international, government policies work to influence both the production and the cost of energy. Regulations, laws, taxes, and financial grants and rebates can be designed to either discourage or promote the use of particular types of energy. For example, homes and businesses can be encouraged to install solar panels by providing rebates for doing so. This has helped over the years to dramatically drive down the initial cost of investment in solar panels, making them more affordable to a wider potential customer base. Many nations and groups of nations, like the European Union, have fuel efficiency standards for vehicles. The idea is to increase the minimum mileage requirement for vehicle manufacturers per unit of fuel, like gallons or liters, thus improving the average efficiency of cars on the road over time. The development and implementation of new energy technologies can be encouraged and supported by providing subsidies for them. Although the fossil fuel industry does benefit from special tax considerations to the tune of hundreds of millions of dollars, the relatively newer and much cleaner wind and solar energy industries receive a financial boost to encourage growth in those sectors. It's also good to note that as more wind and solar energy is adopted, it drives down the cost of production and therefore the need for subsidies. Additionally, with changes in elected officials and other policymakers, often come changes in priorities, which may influence the presence and value of subsidies like these. In many places, construction and building codes demand the use of certain materials to promote energy efficiency, requiring a minimum thickness of insulation, windows constructed with multiple panes, and regulating that appliances like water heaters and furnaces have minimum efficiency standards are all examples of this. Even light bulbs are subject to energy standards. The Energy Independence and Security Act of 2007 included rules to phase out the standard style incandescent light bulb in favor of more efficient compact fluorescent and LED light bulbs. However, progress on energy efficiency is rarely a direct or uninterrupted path, and in 2019, the federal government rolled back the energy efficiency standards for light bulbs. Perhaps the most fiscally significant government influence is the implementation of tax breaks to particular energy-producing sectors. This graph from the federal government's budget office illustrates how certain forms of energy will be prioritized or deprioritized by increasing or decreasing, respectively, through the tax breaks they receive through the 2028 fiscal year. The final way in which governments can exert influence over energy production is by simply banning the construction or use of a particular type of energy generation. That concludes this introductory look at energy resources and consumption. Thank you for watching. Take care.